Okay.
Yes,
And
sir.
Arhan, there was a chapter cell, right? That chapter was left, no?
Yes, sir.
The chapter before reproduction, that is cell. That is that is part of your syllabus, no? Arham and
Sir,
Arhan.
let me check, sir. Sir, let me check, sir.
Okay, okay. So this chapter should be the part of your syllabus as well. Okay. Chapter cell. And you guys have completed the anxiety exercise, right? Of the previous chapter. Mm-hmm.
Yes, sir. I also send it.
Okay, you have sent it also. Very good.
Yes, sir.
Arham, have you completed the previous exercise? Yeah, Arham, are you there? Okay, so let's start the class. Okay, during the later part of the class, you guys can update me regarding the chapter cell. Is that part of the syllabus or has it been omitted? Okay, because
Yes,
in
sir. It is part of the syllabus.
it is part of the syllabus, no? Okay. Arham,
Yes,
you
sir.
also confirm me.
Chapter 8.
Chapter number 8. Good.
Yes, sir.
Okay, because in certain schools, certain chapters are omitted. That's why it's better to get confirmed. Okay, anyways, so today the chapter which we are going to begin with, that is friction. Once we are done with this chapter, we will cover the previous chapter. Okay. Arham, I guess you have already finished this chapter in your school, now. Yeah. Arham. Okay. Arhan, my voice is audible to you, no?
Yes, sir.
Okay, okay. Okay, let me get a confirmation from Arham. Arham, your voice is not, it's too low. I mean, it's not coming properly. Do one thing, no?
I'm just
Mute yourself and then unmute yourself.
now.
No, it's better. So I was asking, this chapter has already been completed, na? Like in the first, in the day, first day we were discussing friction.
Yeah.
Okay, so the chapter has been completed before the vacation.
Now can you hear me?
Yeah, you are audible. I was saying that the chapter has been completed now in your school, friction.
No. Only like a quarter has been done.
Okay, okay, good then. So we are okay to begin with the chapter then. All right. Okay. So guys, basically the chapter is friction, right? Okay, and you guys in our daily life we hear of this term friction, right? So what is this friction now? For example, if you were to push a box lying on the floor with a small amount of force, it does not move now. It will not move at all. It means, what does it
Yes, sir.
mean? The surface of the floor on which this box is lying, on which this box is resting, is exerting some force on this box now, which is which must be acting in a direction opposite to the force applied on it, isn't it? This is a box lying here.
Yes, sir.
We are pushing it here with a small amount of force. This box is not moving. Why? Because there is a force applied by the ground on this box. That force is called as friction. Okay. So in simple terms, this is basically the friction, the force which opposes the motion of one object over another object in contact with it, right? Or we can say that
Yes,
the
sir.
external force that opposes relative motion between two surfaces in contact, right? It is a real external force now. right? Like this force is not coming
Yes,
from
sir.
the body or from the person who is applying the force. Arham and Arhan, it is an external force. An external agent is acting here. Neither am I applying this frictional force, neither this box itself is applying frictional force on the ground, right? So the external force that opposes relative motion between two surfaces which are in contact, and friction acts on the surface of contact between both the bodies. So whenever two bodies will be in contact, only then frictional force will come into picture. Only then we will be talking about frictional force, right? Okay. So for example, here we are pushing a heavy box kept on floor. The two surfaces which are in contact here are what?
Yes, sir.
The two surfaces which are in contact here are what? The floor and
The box, sir.
the box. So they are here in contact here now. Okay. So it will always occur when an object tries to slide over another. This object is trying to slide over this floor. Slide means basically it tries to move over it, right? Okay. Then you will see that there will be always a direction of this force of friction. For example, here it is acting on the left hand side, towards the left side now.
Yes, sir.
So the force of friction always opposes the motion of an object over another object. And the force of friction acts in a direction opposite to the direction in which an object moves. We are trying to move this object in this direction. That is the direction in which we are trying to move it. While the force of friction is opposing this motion here, it is acting in a opposite direction. Getting it? So talking
Yes,
about the
sir.
direction of friction. Right. So we say that the force of friction always opposes the motion of one object over another.
Yes, sir.
No, no. Okay. So further I said the force of friction acts in a direction opposite to the force applied or motion of the object. Force applied or motion of the object. Okay. So here you are applying the force, but still the object was not moving. Then also the direction of the friction was here. This was the direction. Now suppose if the body starts to move, after a while you applied a bigger amount of force. Now the body started to move. Then also the direction of friction is opposite to the direction of motion of this object. Okay, is this clear?
Yes, sir. Can I take screenshot?
Yeah, sure. Okay, Aram is here or not? I guess.
He's
Yeah,
there
Aram.
now.
Okay. Okay, so Aram, we were talking about direction of friction, and we know that
Yeah.
direction of friction is always in opposite. It is always opposite to the direction of applied force and direction of motion
Yeah.
of the body. Okay.
Hmm.
Okay, so take the screenshot, then we will move further.
Yeah, taking.
Okay. Now the question is that what is the cause of the friction? The friction which we were talking about here, what is the cause of this friction here? Hmm? We know that every object has a rough surface. Though the surface may not appear to be rough, it may appear to be very smooth to our naked eyes. But if you were
Yeah.
to have a magnified look, if you were to look at them via a microscope, it is found that surfaces of all objects have rough edges.
Hills and
See this?
valleys. Yeah.
Okay, they see this image over here. They are rough now. We are having a
Yeah.
magnified view here. and they are actually rough in nature, right? So some of the
Yeah.
particles on the surface of objects are in the form of tiny hills, as you can see here. Can't we see some tiny hills are here? Hmm?
Yes. Yes.
While others have grooves,
Yes, sir. Yes,
right?
Hmm.
sir.
So the tiny hills and grooves on the surface of objects are basically the irregularities of the surface here now.
Yeah.
Yes,
Irregularities here, and they kind
Yes.
of lock into each other, they kind of
Yeah. They
interlock into each
interlock.
other.
Hmm.
Exactly, right? And this basically leads to frictional force. So when you are trying to slide one object over another, this interlocking of hills and of these hills and grooves, it basically leads to opposing the force, opposing the motion of the object, right? So we can say here that the friction occurs due to surface irregularities, and friction occurs due to the interlocking of irregularities in the surface of the two objects which are contacting with each other. I know. So we can say that friction occurs due to the interlocking of the irregularities, right, in the s- in the surfaces of two objects that are in contact. Okay, so now we know what is the cause behind the friction. I know.
Hmm. Yeah.
Okay, now moving on. Moving on. See this image over here. Okay, that basically shows the direction of the friction. No? Okay.
it's
Okay. Now another thing here is, what is a relative motion now? Hmm? Relative motion basically says that when one object moves relative to another, it is called relative motion. When one object moves relative to another. For example, you are having two different objects here, object number A and object B. Both are moving at different speeds, right?
Yeah.
So here you will see that both of them are also moving in the same direction. Okay. Now see the second frame. Here in the here we are looking at the frame of road. Suppose you are
Hmm.
standing on the road. You are standing on a road. You are standing alongside a road, and you are having a device by which we are basically having a speedometer, or we are basically having a device using which you can measure the speed of the two cars here. So one
Yeah.
you spotted it to be 30 meter per second, and another 28 meter per second, right?
Hmm.
Now suppose the person in the let's take the frame of car A here, right?
Yeah.
So
yes, sir.
if you were to see, if you were to be sitting in a car A, if you were to be sitting in car A, so you are basically approaching towards car B at a relative speed of 2 meter per second, right? Your speed, the speed of
Yes,
car
sir.
A is 2 meter per second more than the speed of car B.
Hmm.
Getting it? So
Yes,
it will
sir.
Yeah.
appear that it will actually appear that this car B is coming towards you at the speed of 2 meter per second, in fact.
Hmm.
Getting it?
Yes,
Yeah.
sir.
Just visualize that you are sitting in a car, right? And you are
Hmm.
speeding your car at 30 meter per second, while the car ahead of you is moving at a speed of 28 meter per second. So while you are actually moving towards this car, or ahead, you are about to move ahead of this car, but it will appear
Hmm.
that this car is moving towards you at 2 meter per second.
Yeah.
So here we are seeing that two objects, here we are seeing that when one object moves relative to another, it is called as relative motion. Okay.
Hmm.
Now, if you were to be sitting at car B and your speed is 28 meter per second. Okay. So the speed of car is obviously 2 meter per second more than the speed of car B.
Hmm.
So if you were to look at the backside of your car, So you will observe that that car is coming to you at a very fast speed, by the speed of 2 meter
Yes.
per second.
Hmm.
At a speed of 2 meter per second, it will be coming towards you. Okay, and it will seem that at the speed of 28 meter per second, you are moving backward.
Hmm.
Okay, so here we are seeing that motion is relative for different objects,
Yeah.
right?
Hmm.
Okay, then. Okay, the cause of the friction which we have discussed here, right? So it is basically surface irregularities, right? Okay, and these irregularities can be reduced by the help of lubricants. Okay, not in all cases, not for all substances, but for substances whose surface appears to be smooth, but in reality, the surfaces are not smooth, right?
Hmm.
Hmm.
Yeah.
Okay, so on a microscopic level, when we zoom it, we can see that they consist of hills and valleys that are interlocking. So it is due to the interlocking effect, which we have already discussed, right?
Yeah.
Now, there are few terms here like adhesive force. You must have seen that over a long period of time, if two objects are kept in contact with each other for a very long period of time, they start to form bonds and begin to stick to each other. For
Hmm.
example, if you have a, let's say, rubber bands normally which we use, rubber bands, and if you were to place it on a piece of metal, let's say it to be iron, for a long period of time, after a very long period of time, it will start sticking to it,
Hmm.
right? So the surface of rubber band and this iron has started to form bonds between them. Okay, and they basically start to stick to each other. This phenomena here is called as adhesion. This is called as adhesion, right?
Hmm.
And when we try to move objects that are on top of one another, we are basically breaking the bond of overcoming the adhesive force, right?
Yeah.
So when you're
Hmm.
trying to remove it from this iron here, you're basically trying to break the bond between them,
Yeah.
right?
Hmm.
Okay, so see this here. Adhesive forces are the forces which attract the water molecules to other surfaces, causing them to stick. So that is a water molecule here,
Yeah.
right? Hmm. So how it is able to stick to this ground here? It is because due to the adhesive forces, right?
Hmm.
Then you have another concept called as cohesive force. Now, what is this cohesive force? Now, see this water droplet here. This water droplet here consists of so many water molecules. It is actually a water droplet, and it consists of so many tiny water molecules,
Hmm.
right? Okay, and
Yeah.
the attraction force between the water molecules here, it is actually the cohesive force, right? So this
Hmm.
causes this cohesive force that exists between the fluids. This causes fluids to form round shapes where the molecules can be seen
Hmm.
closely packed together as possible, right? So you
Yeah.
have got a fluid, for example, take honey. So if you were to drop a pure honey on your palm or on a surface, it will take a round shape. Now it
Hmm.
takes
Yes,
a
sir.
round shape,
Yeah. Huh.
right, guys? Okay,
Hmm.
so
Hmm.
why is it so? Because the cohesive force is trying to trying to keep all the molecules together, so it acquires a round shape, right?
Yeah.
Okay,
Hmm.
so it is the um force present basically between the molecules of the fluid. We can say that that is called as cohesive force. Then you have adhesive forces, basically when two surfaces are in contact. Here the surface of this floor here, let's say to be a floor, and the surface of this water molecule, that is this here. So they are here
Hmm.
in contact here, and the force that is developed between them will be called as adhesive force. Hope that is clear.
Yes. Yes, sir.
Okay, okay, good. Okay, moving on. What is this blowing effect? The question is that what is this blowing effect? Hmm?
Hmm.
Look, When you have got a when surfaces are soft, or can change its shape easily, they get deformed when they come in contact with another object. Example, you have
Hmm.
carpets. So when a heavy object is placed on them, it looks like a valley that is caused by the deformation of the shape.
Hmm.
This effect of the surface sinking into another is known as the plowing effect. So here, this is basically a piece of carpet. Okay. And here you have placed a heavy object,
Yeah.
right? So at your homes, if you have carpet, just place a heavy object on it. Okay. And just
Hmm.
move this carpet slightly, right? So you will see that valley like a structure is formed, like this valley here is here the valley is forming. Valleys are
Yeah.
forming here,
Hmm.
right?
Yes, sir.
So that is simply called as plowing effect. Okay. So in plowing effect, what we see that surface sinks into each other and gives rise to plowing effect. Okay.
Yeah.
Hmm. So it basically will be seen in soft surfaces, which can change their shape easily, and they get deformed when they come
Yeah.
in contact with another object,
Hmm.
right? So that is a plowing effect. Okay. Now, what are the factors that will affect the magnitude of the friction? Hmm? Like
Hmm.
friction will be lesser in some case, it will be more in some case. So what are the factors that affect this? Hmm?
It depends on the surface.
Hmm? Surface
So the
smoothness,
amount of force.
the amount of force with which the two objects are pressed across each other,
Yes,
right?
sir.
Hmm. So basically it depends on the nature of the substance, right? And
Hmm.
then it is the force with which they are being pressed here. Okay.
Yeah.
So Arham, read this paragraph here.
Factors affecting friction
Hmm.
depends on the nature of the surfaces in contact.
Hmm.
Friction exists between two surfaces. For example, glass and rubber.
Hmm. Read further.
Nature of surface in contact. Friction depends on how hard the two surfaces are pressed together. As more surfaces are in contact and
Mhm.
more bonds are formed. More bonds to break means more friction. Only the
Hmm.
normal reaction force exactly perpendicular to the
Hmm.
surfaces increases the friction.
Hmm. Exactly here. So you see, first thing we talked about is the nature of the substance, right?
Yeah.
So in the nature of the substance, we are basically looking for the roughness only, right?
Hmm.
This roughness, that is basically the nature. Okay.
Yeah.
Then how hard the two objects are being pressed each other, with what force? With what force
Hmm.
they are being pressed against each other. So that will also determine the friction between them. And the area of surface contact also determines, more the area is in contact, more will be the frictional force,
Yes,
right?
sir.
Because more bonds will be forming between the two objects if they are left for a long period of time, right?
Yes, sir.
Okay. So uh look here, two things we have discussed here. Okay. The statement which I just said, that it will depend on the amount of surface area, in many cases it is contradictory. Why is it so?
Hmm.
Hmm?
Um.
We know that it will depend on the nature of two surfaces. Okay. But it will not, the thing is that it will not depend on the amount of surface area. Why is it so? Mhm.
No idea.
Any idea, Arhan?
No.
It does not depend on the amount of surface area. Why is it so? Look here. We know that friction depends on the smoothness or roughness of the two surfaces which are in contact with each other.
Yes.
Okay.
Yes, sir.
And right, when the two surfaces are smooth, then the friction between them will be small here,
Yes. Yes, sir.
right? So take example two substances here, right? These
Hmm.
two substances here, and the
Yes, sir.
same two substances we are taking of same sizes, right?
Yes.
Okay. In this, there is roughness here. The
Hmm.
surfaces are rough, and here the surfaces are smooth.
Yes.
Okay, the surface area in both the cases are same here, in case 1 and case
Hmm.
2. Okay, so here is the contradiction now. Earlier we were discussing that if the surface area contact is more, friction will be more. But we forget about
Hmm.
the one more factor, that is the nature of the substance. So here it's smooth,
Yeah.
so friction is less now.
Hmm.
Friction is less. Here friction is more, right? So that's why
Yes.
we can't conclude that frictional will depend on the amount of surface area,
Hmm.
right? So we can see
Yeah.
that friction does not necessarily depend on amount of surface area, right?
Yes.
Okay, all right. Now let's understand how do we calculate frictional force using a spring balance. Okay, study the figure. What are the things which we can observe here? Mhm. Study this figure. We have placed a block over here, right? We have
Yes.
provided a support by
A
this
table.
table. Hmm.
Hmm.
Now we are trying to pull it in this direction, right? And a
Hmm.
frictional force is also a friction that will act in this direction here, right?
Yes.
Okay, and this force of gravity is also acting upon it. The
Hmm.
small g force of gravity is also acting here.
Yeah.
Okay, so whenever you will be discussing about any type of forces acting on the object, we have to consider all the forces acting on it, right?
Yeah.
Okay, so here the reading shows that you are pulling it at 5 at a force of 5 newton, and the object has started to move.
Hmm.
The object here has started to move. So now if you were to be applying, if you were applying 4 newton of force, the object does not tend to move. You were applying 4.5 newton of force, the object does not tend to move here, right?
Yes, sir. Hmm.
Okay, so what does it shows that the amount of frictional
The
force.
frictional force is more than the applied force.
No. Yeah, that is the case. The amount of frictional force is more than the applied force, that is 4 and 4.5 newton. But as soon as
Hmm.
we applied this 5 newton of force, the object started to move, right?
Yeah.
So here
Hmm.
you are taking place of a spring balance. It is basically a device which is used to find friction, okay, and used to
Hmm.
calculate weight of object as well, right?
Yes.
Okay, so talking about the composition, talking about the structure of this spring balance, it is
Hmm.
basically this spring balance contains a coiled spring, right, which gets stretched it is when a load is being pulled using this, right?
Yeah.
And the
Hmm.
amount to which it has stretched, that basically gives the measurement, that basically gives you the
Yes.
magnitude of force, right?
Yeah.
Okay, so
Hmm.
in this case the magnitude of the force here is 5 newton, right?
Yes.
Okay.
Yes.
Any confusions?
No.
Okay, good.
No.
Okay. Okay, so far the things which we have discussed, yeah, so far we have discussed what is friction, then we have talked about what are the causes of the friction, right?
Hmm.
Then characteristics of the friction, how do we calculate it? Now,
Hmm.
depending upon the shape and size of the surfaces, you will see frictions will vary, right? For example,
Yeah.
if you were to throw a ball on the ground, after a while it tends to stop. Why is it so? Because
Yes.
it is experiencing a force. But if
Yeah.
you were to throw another object on the ground, right, you will see that
Hmm.
it will not move a larger distance.
Yeah.
You're throwing a ball on the ground, it will move to a considerable amount of distance. But if you were to roll a dice in the ground, okay, just slide a dice on the ground or a square box, it will move to a small distance only, right?
Yes. Hmm.
Okay. So depending upon the shape here, different types of frictional forces are there. Okay.
Hmm.
So next topic is types of frictional forces.
Yeah.
Okay. So what are the types of frictional forces, guys? Hmm?
Static friction, limiting friction, and kinetic friction.
Okay, look here. One is the rolling friction.
Rolling friction. Yeah.
Okay.
Sliding friction.
Then you have static friction also.
Yes.
Static friction. Then you have sliding
Sliding
friction,
friction. Yes.
right? So these are the types of basically the types of friction which we are going to be
Hmm.
discussing today, right?
Yeah.
Okay. So let's talk about the rolling friction. Okay. So what happens in rolling friction? Basically, when an object is rolled over another object, the type of friction that comes into picture, that is called as rolling friction, right?
Hmm.
Okay. So, for example, that is a classic example of a ball here, right?
Yeah.
Okay. One more friction was there in rolling friction. You can also call it to be as kinetic friction as well here,
Yes.
right? The
Rolling and
case of
sliding, right? Both.
rolling and sliding as well. Good.
Hmm.
This one also has can be categorized as kinetic friction also. Getting it?
Yeah.
Okay. Okay. So rolling friction is quite simple. As we said, when an object rolls over another object, the type of friction generated is called rolling friction,
Yes.
right? What are some of the applications of rolling frictions on this? Sorry, Arhan.
Yes, sir.
What are some of the application of this rolling friction? Where do we use it?
Sir, sir, like playing football, we roll the ball.
Okay. I'm actually asking about the devices in which rolling friction, in which you will find application of rolling friction. Hmm?
Sir, I don't understand.
Look here. The wheels which you see in cars, right? There you see the
Yeah.
example of rolling friction.
Yes.
Okay, and in
When
the
we have to move anything.
exactly in the wheels you will see there's a thing called as ball bearings.
Hmm.
Suppose this is a cycle here, right? Suppose that is a cycle over here. Let's say let's just take the front part. So this thing here, it is this thing here with which the handle is attached. That is called as ball bearing now,
Ball there. Yeah.
right? So this part of the bicycle basically consists of ball bears, right? So in which you have got small balls, small iron balls,
Hmm.
right? Small
Yeah.
iron balls. So what happens when you use this small iron balls? The area of contact is reduced. Since the area of
Yeah. It's
contact here is
less.
reduced, it is less here. Also, you will see that friction is reduced here, right? So you will see
Yeah.
that
Hmm.
friction will, you will see that rolling will provide you less friction as compared to whether it's sliding
Sliding.
friction or another friction,
Static friction.
right?
Hmm.
So we can say that application we have discussed, for example, in cars, bicycles, right? Okay, so one more thing we may conclude here, that rolling friction is lesser than the sliding friction, the next friction which we will be discussing.
Yeah.
Right. Okay. So machines which we there are several other machines also which uses ball bearings to reduce the friction of moving parts. Right.
Yeah.
Okay. Now then you have another example, another type of friction that is called as sliding friction.
So there was one more example
Yeah.
of friction, right?
Uh, one more example of which one? Rolling friction.
No, sir. Fluid friction. There was another friction.
Fluid friction. Yeah, that one also we will be discussing. Right.
Okay.
Okay. Now, what is the sliding friction, Arhan? You explain this. Mhm. Sliding friction. Basically, whenever a body is being slided over another body, the
Another
friction
body. Yeah.
that comes into picture, that is simply sliding friction.
Yes, sir.
Hmm.
Right. That is the thing here. So when an is slided over another object, the friction that develops is called sliding friction. Okay. So here you have classic example of a box here. It is being slided here. So to slide this square box over another on the floor, the amount of force required is also higher. The amount of friction generated is also higher.
Hi. Yeah.
Right. So we conclude from this here that sliding friction has got more friction than the rolling friction.
Rolling friction. Yeah.
Right.
The area because the area of contact is more.
Here, sliding friction is greater than the rolling friction. Right. And what are some of the side effects of side friction?
Um.
Yeah, more amount of heat is generated.
Heat. Yeah. More heat energy is
Right.
developed.
Exactly. More heat is released, right? Or the surfaces might also get broken, right?
Yeah.
Okay. So due to this property, it does not have any applications in daily life, right?
Hmm.
Okay. By the way,
Yeah.
one aspect of the chapter we completely missed at. What are the advantages of frictional force in our daily life?
Um.
Mhm.
uh, if there is no friction, there is no friction, all the things
Mhm.
will roll over and just
Mhm.
slide everywhere.
That is it. Oh, okay. That is the explanation basically. What are some of the applications I'm talking of? The applications, advantages. Let's say what are the advantages of frictional force? Let's say you have burning matchsticks now. How we are
Yeah.
able to
Ah,
burn
yeah.
the
Sir.
matchsticks due
Mm-hmm.
to
Yes, sir.
friction. Okay.
Yes.
You have got spiked shoes now. Okay.
Yeah.
So the cricket players and football players, they use spiked shoes,
There are spikes below their
right?
shoes. Yeah.
The tires of the car,
Hmm.
is it smooth or
They
rough?
have grips.
They have
It's
grips
rough.
in them, right?
Hmm.
Okay. Uh, now, is it easier to write on is it easier to write on a piece of glass using a pencil, or is it easier to write on a paper?
On a paper.
The paper.
On a paper, obviously, right?
Yes.
Okay. In the construction of buildings, let's say if the surfaces were too smooth, will the construction be possible?
No.
No, right? So if there was no friction, all the bricks, all the construction materials, they will start to slide over each other and the building will basically
Yes,
collapse,
they will roll. Yeah.
right? So friction also allows us to fix a nail into a wall. It is due to the friction why
Hmm.
it gets held there, right?
Yes.
So it has got a number of applications in daily life. Okay, what are some of the
Yeah.
disadvantages?
Friction produces heat, which sometimes can lead
Heat.
to many wrong things.
Mm. So
They
it
sometimes
produces
take
heat.
so much force.
Yeah, it requires so much of energy. Good.
Yeah.
Okay, what else? For example, you see why there's so much of noise produced whenever an aircraft passes by or when an aeroplane passes nearby.
Yes.
Why
The
there's
air
so
is
much of
acting
noise
as the
pollution?
friction.
Exactly, it is because of the friction developed between the airplane's surface and the air. So that
Hmm.
basically leads to noise pollution, right? And
Yes.
then you have wear and tear of materials for example, wearing of shoes, the sole of the shoes, right?
Yes.
Okay, and the wildfires. What is the cause behind the wildfires?
Yeah. Heat is produced and um.
Hmm. Basically, in the deciduous forest specifically, you will see, or in the grasslands,
Yes.
fire is wildfire is common there. So what happens during
Yeah.
summers? All the trees are basically dry. They have lost the
Hmm.
water in them. So since they are dry and hot winds blow there, the branches get rubbed across each other, right? So the
Yeah. The
friction is
roots
produced.
gets loosened.
Hmm, exactly. So due to the friction, you see wildfires are there. So these are some disadvantages now.
Yeah.
Okay, one more question to both of you. How can we reduce friction and how can we increase friction?
The lubricated,
We can.
the lubricant,
Hmm, good. We can use lubricants and
We can
you
reduce
talk.
the
Hmm.
amount of uh, the applied force. You can reduce the applied force.
Applied force. Okay, we can do that. And then we can also um, change the
Make the
pattern
surface
of the,
smoother.
make the surfaces smoother, right?
Yeah.
Okay, we can also reduce the surface area contact. Remember, I
Yes.
told you that it is not necessary. It is not necessary that removing, decreasing the surface area contact will necessarily decrease the friction, because
Mm-hmm.
we had example
Yeah.
of
yes,
that
sir.
smooth glass and another rough surface. While
Mm.
if you have two surfaces, both of them are rough. Okay,
Mm.
so in which case the friction generated is lesser, case one or case two?
Case one.
Case two.
Case two, no, friction will be lesser here, no?
Yes.
Both of them
The
are
area of
rough, but
contact is
the,
also less.
yes, area of contact here is lesser. That's why friction is going to be lesser, right? Okay, and give some
Mm.
examples. How can we increase from daily life examples? How friction is increased?
So by increasing the force,
Mm. By increasing the force. Okay, good.
so
Okay,
by increasing the surface area,
Mhm. You guys are you guys fan of car racing? Formula One
No.
car racers. So you see, me,
kind of, sir.
meanwhile the race, their tires are regularly changed,
Yes. Yes.
right?
They
Right.
burn out.
Yeah, exactly. They will burn out if they will not be changed. So patterns, there are
Mm.
patterns on the surface of tires, right? So there are some
Yeah.
certain patterns are made to increase their grip over the roads, right?
Yes.
Okay, that is how they are increased. The friction can be increased. So friction can be
Mm.
good, friction can be bad as well. Okay. So one more thing here is, someone told Arhan told me about lubricants. So there are different types of lubricants which we use. For example, we have got oil. Okay, but oil can't be put everywhere. There are certain
Yeah.
devices where you
Yes,
can't
sir.
put oil, right? So there you will be using grease.
Mm.
Okay, but then again you have some mechanical devices where you can't put grease also. So then you have graphite powder. Graphite powder. Right. So graphite powder is
Hmm.
also used as a lubricant. Getting it?
Yeah.
Yes, sir.
Okay then. So coming back to our discussion, we have time left now. Right. All right, we have enough time left. Okay, so we were talking about sliding friction. So in sliding friction,
Hmm.
one of the disadvantages we saw that more heat is released in this case,
Yes.
right?
Hmm.
Okay.
Yes,
So
sir.
sliding friction here was the force that was opposing the movement of the slide of the object over it. It was the
Hmm.
force of friction that was opposing the slide of this box over it, the floor.
Yeah. Hmm.
Okay. Then talking about static friction.
Hmm.
What is it?
When the applied force is not enough
Sir,
and the force is applied but the object is not moving.
yes, sir.
Hmm. Hmm. The frictional force that comes into play until an object starts moving is called as static friction,
Static friction.
right? So an object has
Hmm.
to overcome the static friction force in order to start its movement, right?
Yeah.
Getting it? Okay. For example, there's a car at rest. Okay. In order to move, the car needs to at least overcome the static friction,
Yes.
right? Okay. Now notice the word here is static. Static here basically means rest. Okay.
Hmm.
So we can also say that the friction that has generated between the two surfaces when they are at rest, both the surfaces are rest,
Yeah.
right? This object here, this is a ground here, right?
Hmm.
So we can also say that it is the frictional force that develops when two objects are placed at each other and both of them are at the stationary position. Getting it? Okay. So we basically need to overcome the force here that has developed between the two surfaces in order to make the object acquire some motion. Okay. All right. So that is basically the static friction. And in real life, it has not anything such as application. Basically, the objects which you are seeing at rest, it is due to the static friction. Okay. So we can say that the frictional force that comes into play, right,
Hmm.
when an object starts moving is called static friction, right?
Yes.
Us to overcome this force in order to move. Okay, so hope that is clear. Okay,
Yes.
then
Yes,
you
sir.
had one more example of fluid friction, right? So what is this fluid
Hmm.
friction now? As the name says that the friction that is basically exerted by fluid. Okay,
Hmm.
so whenever an object moves in a fluid, for example, let's take example of a person, right? Or take example
Hmm.
of a fish. The fluid is also exerting a type of friction upon the object that is called as fluid friction. Okay,
Yes.
and this fluid is it is referred to in a more general way. It is referred to both air and water as well, right? So, for example, if an aeroplane is flying, it is also experiencing air friction, right? You have an example of an aeroplane flying. It is
Yes.
observing friction due to the air. So here it's air friction, right? You have example of fishes,
Hmm.
right? So the friction that is being experienced by this fish due to the water, that is water friction,
Hmm.
or better to call it as fluid friction,
Yes.
right? So This is the case, right? So whenever the medium of travel is air or whenever the medium of travel is water, right? So the type of friction being experienced by the object, that will be called as fluid friction. Okay. Any confusions?
No.
Okay.
No, sir.
Okay. Now we may conclude one thing over here, that we had the example of sliding, rolling friction first, right? So example, you had a slender piece of cylinder here. You are rolling it,
Hmm.
right? Rolling friction. Then you have example of an aircraft flying in the air.
They're rolling a trolley cart.
Yeah, that is also an example. That is basically a aircraft.
Hmm.
Okay. Then you had example of a sliding friction.
Yes.
Now, the question I am posing to both of you is that do tell me, in which case the amount of friction experienced by the object will be maximum.
So can you
So
repeat?
can you repeat the question?
My question is that here you have example of rolling friction, right? This is your
Yes.
fluid friction.
Hmm.
Fluid friction. Then you have this example of static friction.
Static friction.
Sliding. This is sliding.
Sliding. Yeah.
Right. And then again, take one more example. Take example of static friction also.
Hmm.
Here you have example of static friction. Now, out of all these forces, arrange them in the ascending order of their magnitude.
Sliding friction is first. No, static friction. Static friction is first.
Yes,
No.
sir.
Mhm. Ascending order from smaller to bigger. Look here.
Then fluid friction.
Then it
The
is
rolling friction.
rolling friction will be first. Okay.
Yes,
Then
It
then
is,
Then fluid.
then you will be having sliding friction.
yes, sir.
Getting it?
Then the static friction.
Yes.
Then a
No,
static
then
friction.
fluid. Oh,
No, then a static
Then
friction.
the fluid friction.
then fluid.
Right. Then the fluid friction will be there. So we can
Yes.
conclude it like this. The rolling friction. Then you have
Sliding friction.
sliding friction. Then it is static friction.
Yes.
Okay. Then you can continue the series with all other types of frictions as well. Right.
Yes.
Okay. All right. So that is it for today. Okay. So we will continue our discussion further with few more important
Chapter
topics.
is finished, right?
Okay. No, the chapter hasn't been finished. We have basically covered all the topics, but in a more comprehensive manner. Few more things we will be discussing in next class.
Okay.
Okay.
Sir, can you
Allow.
provide us with the slide?
Yeah, sure. The
Since,
slide of the the slide of the previous one I will send that.
okay, sir.
Okay. Few important things are left in the class to go. For example, in the case of fluid friction,